Good afternoon, everyone, and welcome to this Canary coaching session, Calculations 201. My name is Jeff Nepper, and I'm excited to build on top of the work that Kyle Kinsinger had done in a previous session. That would be the 100 series on calcs. Kyle is with us here today and will be in the chat to answer questions as you have them. So feel free to fire questions off in the chat as need be. Today's agenda, as I mentioned, we're going to build on top of the work that Kyle has already started. So we are going to start off by building calculations based on asset types. We're going to look at all of the various aggregates that are most commonly used around asset calculations. We're going to build tiered calculations, meaning multiple expressions and calling those expressions within other expressions. We'll take a look at some logic or condition-based calculations. And as a bonus, when we end, we're going to build out some health matrices, how to take assets and assign health scores to them using the calculation engine. So let's get started. The very first thing that I want to do is to go ahead and open up my Canary admin. And Kyle mentioned this in the last training session. I want to reiterate it. When working with calculations, it's always a good idea to come into the historian and build a separate data set or even data sets for your calculations to have as a destination. So I've built a brand new data set called calcs. Currently, there are no HDB files in it, meaning we've not done anything to it. So as we are building our calculations will use the local sender service and publish this data into the calcs data set. All right, so as you can see, I'm starting from a blank slate. We do have a virtual view already built, and that virtual view is the same one that we use in our boot camp. So if you're familiar with the Canary Boot Camp, that resource is available to you in the Learn section on the community. You can actually download and duplicate this work. So we're going to use the Roadshow Water District. At the highest level, I have a company. Company is divided into 4 different districts. Inside of a district, I have stations. And then within stations, I have pumps and I have towers. Now today, we're only going to deal with the pump and pumping station. But a pump, just so you know, has these 5 tags: flow state, total volume daily, yesterday, and vibration. Now, if I look at my view and look at the definition on my view, you'll see that I'm also watching this calcs data set. So as I publish new calculations to the calcs data set, I've already accounted for them in the rules for my view. So after about a minute after I start publishing calculations, those new calculated tags are going to show back into my virtual view. We'll offer additional training on how to do this, or you might be able to look through the documentation in our virtual views and see how to do that. I just wanted to help connect the dots on how the calculations are going to be showing back up. Okay, let's go ahead and start with a new calculation. We'll label these water district. And this first one is going to be basically pump stats. Since I want to build it on an asset type, I need to first select the virtual view, otherwise known as the asset path. The virtual view we're going to use, and then pick the asset type. Like I said, pumps. We are going to backfill everything in this calculation until 9 a.m. this morning. I could pick farther back if I wanted to, but I just want enough history to be able to show you the backfill process. I'm going to use periodic, and we'll leave the default of 5 minutes. First thing to do, set an expression. So I can look at my function list, and my function list is going to give me all of the different available functions that I have. Let's go ahead and start with the most basic and common application, time average. We support the OPC Foundation's definition for time average and time average too. It's just a change in how they handle the bounding values, the first and the last value in the set. You can get those definitions from the OPC Foundation or also in our documentation on the Help Center. So when I hover over, the tooltip gives me the definition, and below the function here at the bottom of the window, it actually gives me the format. Now, it might be a little difficult for you to see the formatting, so I'm going to go ahead and share this with you. We're going to place our function, in this case time average 2, parentheses for the entire function, single quote, square bracket, tag path, square bracket, closed, quote close, comma, space, single quote, duration, single quote. So let's do that now. You can see that we've given the parentheses and we've given the comma and the quotes. So if I place my cursor between the two quotes, I can now browse my tag list. I only want asset tags. I don't want all of the tags in the historian, so I'm going to use the Asset Tags tab, and there are the tags associated with a pump. Let's do a flow. Notice that the flow has come in. I know the tag path is recognized because of the color change, and it's in between the quotes. Now I'll cursor in between the next set of quotes, and now I pick my duration. Simple duration, let's look at the last 1 hour, 1H. I want to explain a little bit about this tag path. Again, it might be tough for you to see that, so I'll show you here. The tag path starts with the view name, in this case, my roadshow water districts, dot, and then it has this %asset% dot, and then the actual tag flow. The %asset% is a wildcard or a variable that allows me to reference the current selected asset. So roadshow water district's my view name, flows my tag, %asset% is being replaced with this asset information here. So when I hit evaluate, I'm seeing the last 1 hour time average of all of the raw values for flow for Kamal Station 1, Pump 1. If I switch to Station 1, Pump 2, it reevaluates, and the %asset% is essentially telling the expression to reference this asset. Now that means that at the same time, if I output this tag, when I output it, I want to output it to my data set, calcs, but I want to output it with this piece of information for each of the assets. And so I'm going to call the %asset% back into the output tag, dot, and then give it the tag name. So we'll just call this flow 1H average. I could stop there with my tag name, but I like to actually label my calculated tags as calculated tags so that my users know that what they're looking at is not a logging, live logged tag, but a calculated tag. So I typically do an underscore calc at the end. And again, wants to show you a bit of a close-up. I'm calling the dataset calcs dot, inserting that asset wildcard %A asset% dot, and then whatever calculated tag name that I'd like to use. Now I can also add metadata here. Metadata, I provide the property name. In this case, I'm going to write to the description field. And then I do a double colon and put in my value. So I'm going to just simply label this as and let's see, I'm calculating every 5 minutes. So now that will write as a description. And if, for instance, I wanted to add another one, I could do engineering units, double colon, and say that's in gallons. All right, so we evaluate, and there we have our time average 2 tag, runs every 5 minutes, looks backwards 1 hour when it runs, and currently is assessing this pump, has calculated that value. The output quality is good. And there's the timestamp that will be associated with this tag. Now, I do have 2 other fields I want to talk about. I have an offset field and I have a delay field. So currently I'm running this every 5 minutes. And so I would have an output here at 1340, 1345, 1350. If I wanted to change that output time and offset it forward or backwards, I use this field. So if I want to offset it backwards 1 minute, now I can, offset it, forwards 1 minute. Now I can move it forward by 1 minute. 4 minutes forward would essentially offset it backwards by 1 minute. There we see. So that's the offset feature. Something like a 5-minute interval, you may not use that. But if this was running, say, once every day, and I wanted to actually run it at 8 a.m., well, then I could run an 8-hour offset from midnight, and that would give me my 8 a.m. evaluations. That's offset. Let's talk about delay. If I was running this calculation once a day, and I am collecting a lot of data from assets maybe that are on comm networks that might have some type of built-in delays or just difficulties in collecting the data with low latency, I might want to actually delay this calculation from running. So let's say that once a day at midnight, I want to trigger this calculation. That means that at midnight, it runs based on the previous 24 hours worth of data. Okay, so all of the data from yesterday is now being used in this time average calculation, and it's running at midnight every day. I can still run it for the 24-hour period from yesterday, midnight to midnight, but I don't have to execute the calculation exactly at midnight. So if I delayed this, say, 10 minutes, it would actually perform the calculation at 12:10 a.m. based on all of the data from midnight to midnight the previous day. So this delay gives your system some time to get all of the data into the historian. So if you have bandwidth issues, if sometimes you find yourself going into store and forward for 5 seconds, 30 seconds, bad cell service, whatever it is, the delay gives you the ability to account for that. All right, let's do a few more of these just for illustration purposes. I'm going to move back to 5 minutes, and we'll leave that one at 24 hours. The plus button gives me another expression. So these expressions can be left without a variable, or I can reference these as a variable. So I could say A is now time average. And that was time average from the last 24 hours. Here, let's do a different function. Let's do something like our total 2. So here's our total 2. We'll do the same tag, flow. Then we'll run the total 2 for the last 24 hours as well. So there's the average of the flow. There is the sum of all of the flow values in the last 24 hours. Other functions, just to point out that this simple format is commonly used, include things like count, where it would give me the number of actual value changes. I can do that for specific booleans of state 0 or non-zero, deltas, deltas that are a totalizer that might have rolled over throughout the period, maximums, minimums, number of transitions on a Boolean, ranges, our totals, standard deviation of population and sample, variance of population and sample. These are all pretty common applications of those functions. I'm going to delete this one. Now let's do something a little different here. We'll bring this one to 1 hour. And I'd like to show you a way that you can actually, instead of rolling a constant 1 hour backwards from now, that's what this does. Every 5 minutes, it looks to now, the 5-minute interval, and looks backwards 1 hour. Well, if I wanted to anchor it and say, no, I don't want to do it that way. Instead, I want to know what is the value for the previous 8 hours. And I want you to do that from the start of the day. So here I could type in day, which is my start time. And now if I was doing this once a day as my interval, I would have perhaps my first shift, if my shift ran from midnight to 8 a.m. That's because I'm in the future. 1 second. I need to go day -1, D. There we go. So now I have the ability essentially to come in and set my anchor time as yesterday morning at midnight, look forward 8 hours from the morning, and then this is going to run tonight at midnight. I can do the same thing with days of the week, Monday, Tuesday, Wednesday. I can say month, I can say week, I can say year, I can call specific dates and periods of time. So if I wanted to say 10:25, 21 at 8 a.m., that will also work. So that's the start time. And you'll see here in the bottom right-hand corner, documentation again on start time. All right, let's move to a different series of functions. Before I do that though, I should go ahead and just backfill some of this. So let's get some calculations going. I'm just going to say 1 hour running every 30 minutes and evaluate, looks good. So it's going to run this for 47 pumps. I'm backfilling it to 9 a.m. and let's deploy it. Close it. And now we're ready to deploy it by pressing the play button. All right, so in my status, I've already backfilled. I'm now live. I've calculated for all 47 assets. I made a total of 470 TVQ stores, as well as my description and engineering unit properties. And so every 30 minutes, it'll run another 47 updates, and I'll see that number climb. Let's add another one, and this time we're going to use the durations features. We'll do some pump states. And we'll stick to periodic. We'll just let it go every 1 hour. Every 1 hour, I'd like to know what has been my time of state for my my Boolean that's measuring whether I'm in manual or automatic mode. That's my state tag for my pump. So I'm going to put in my my duration in state non-zero. This is going to tell me the amount of time I've been in manual mode for this tag, looking back the last hour. So so it runs once an hour, looks backwards at the top of the hour for an hour, and returns the amount of time in milliseconds that I was operating in a state non-zero. So it returns 0 milliseconds. So I know that I was in automatic the entire time. Let's look at 2. Returns 3.6 million milliseconds, which I know is all of the milliseconds within the hour. Let's see if we have any that have been more in between. If not, we can look to day and maybe we'll get some for day. All right, let's switch it up to a day just so that I've got some very generic data here. And in that data, it's difficult to get real great mapping of real world scenarios. But this is not a full day. It's not 0. Now, if I want to see this converted, I can take these functions and I can include them with more of my expression, meaning simply I can say, hey, you know what, return that in seconds. So I divide by 1,000 milliseconds, and now that's seconds. I could say return that in minutes, divided by 60,000. Okay, 1,107 minutes. Or I could make that 36, 3,660,000. And there I am in hours. So 18.14 hours in the last 24 hours, this was running duration in non-state 0. Other functions for duration include the duration that my quality score was bad or good. All of these return in milliseconds, mind you. Duration since last historian update tells me the number of milliseconds since my tag that I've named has received an update. Can be very useful in monitoring tags that you might worry about they've lost connectivity, or they were supposed to, totalizers that are supposed to change once every, say, 30 minutes. I can measure those. And duration since the last TVQ. So that's not about the update changing, it's about the last TVQ that got reported to the historian. Now, with these durations, I can do some other things as well. I can use this duration since date time. Let me show you how. We'll build another expression. Duration since date time. And here I just give it a start time. So I could say since the beginning of the current hour. And it's going to return the number of milliseconds since that point in time. So let me switch this over. The interval of 24 hours is why you're seeing it tell me that I'm off in my looking forward to the time. But let me just switch this over to day. I might change that top interval. Let me get rid of this. We're going to say, let's do it every 5 minutes for now. All right, so since the start of the day, I've had this many milliseconds. Show you, I could label this as an expression of, this expression is a variable of A. And I could come in here and replace this time duration with the quotes and say A. I just have to reorder, and then I can evaluate. So I've named A, and then the next expression down, it's giving me the duration in state non-zero based on the time period of A. Now I could do the exact same thing like this as well. So what's the duration of state 0 for this tag? Since midnight, there it is. And if I wanted to know what's that in minutes, I've now got my minutes. And if I want to convert that to a percentage, let's put this entire first piece in a quote. And let's divide it by the total duration. Multiply it times 100. There we go. 1 sec. So we can see that 9.05 e to the negative 0.6. So hardly any time at all. So as a percentage, I'm less than 1% of time in zero on this asset. Let's go with another one. This one has been 0%, and I could keep going down the list. So that gives me ultimately a path to use an expression to embed that expression into another expression and build off of this. I want to go ahead and, as we've checked through the tiered calculations, show a way that we can use these outputs as a actual health matrix as well. So let's come down here and let's do a little bit of a if logic statement. So to keep it real simple, first, I just want to look through some of this data. Let me delete that expression. Notice that we do have this error message up here. So these error messages are built to help me identify when I have an error in my expressions. It tells me where the error is. If the error is here on this expression, it would actually tell me where. It doesn't like to have a blank expression. That's why I deleted that. I'm just looking through right now and trying to get a sense of my assets. So this one's been in state 0 for a bit. That's what's going on. It's in there in my head not liking those percentages. I'm short a quote here, aren't I? Yes, I am. Or a parenthesis. I was in there not liking those percentages, and it's because I was dividing it by 60,000. I shouldn't have been trying to convert it. So there we go. 98.9% of the time, we have sat in non-zero on this asset. Kamal 2, we've been in non-zero for 54% of the time. Kamal Pump 1, 0% of the time. So now I want to build a little bit of a health matrix, and I'm going to use a logic statement. I'm going to say if, and then we'll name this, we'll call it T for time, or actually P for percent. If P is greater than, let's say 90%, then this is unhealthy. We don't want to be in manual mode that much, so we're going to write we'll give it the lowest grade possible. We're going to write a 1. If P is greater than 70%, we're going to write a 2. If, you see what we're doing here, we're just gradually reducing 40%, we're going to write a 3. If P is greater than 20%, we will write a 2. And if not, we're going to write a 1. So let's see, how many did we have? 1 closes that, closes that, closes that, and 4 in total. So I've built a little bit of a health matrix. I'm writing a 1 value here because this has been at 0%. And on this one, it's been at 54%. So I'm writing it's greater than 40%, under 70%. So I'm writing a 3 on this one. Makes sense. Now I could do the exact same thing. That gives me a scale of 1 to 5. I could do the exact same thing as I've done here on this tag. I might do for my flow tag. So let's just take a look at the time average on my flow tag. And we're going to do the same thing. We're going to call that since our duration since daytime. Let's make sure that that evaluates. And it does. And what if I divide that by what my value was yesterday? And then multiply this times 100. That's going to give me a percent of what I've produced so far today or what I'm tracking to produce, I should say, today based on my average compared to yesterday. So now I could come in here, label this, we'll call this one, that one was percentage, we'll call this one V for volume. Now I could come in here and write another expression. And this expression could reference my V for volume tag. And essentially, I could change these values around. If it's greater than 100, then we're going to give it a good value of 5. And if it's, we'll leave the 70s alone, 4, 3, 2, and 1. So that's perfect. And I'm looking at this and realizing up above 3, I went the wrong way there, didn't I? That should have been 4, and that should have been 5 in my assessments. Okay, so this one now is X. This one now is Y. I evaluate, Y is scoring this at 5, X is scoring this at a 3. So now if I just add X plus Y, I've got a health evaluation. I can write the tag out, calcs.percent asset percent, and we'll call this health score calc. I could put in my metadata so this number has context to the users. Ultimately, we're going to run this thing every 5 minutes. I've backfilled it to, I'll just do it to midnight this morning. We'll apply it, close it, and execute it. It's already through backfill, getting ready to move into live mode. It's made over 6,000 calculations as it's running through the backfill. And then in my views, when I look at my assets and look at my pumps, I've already got the calc for the flow 1 hour average. The health score is getting ready to come in. While we wait for that, I want to show you one last feature, and that's the roll-up and our parent asset feature. Let's do district assets. So same asset path, water district, but this time I'm going to pick the asset type of district. Remember, district has pumping stations, and pumping stations have pumps and towers. So I've got 4 districts, and here I'm going to use the function called rollup. Rollup allows me to target my asset path, roadshow, space dash, space, water, district, and then I add the asset wildcard, just like so. Let me show it to you closer. Rollup, view name, dot, percent asset percent. A little tricky here, no dot at the end of the percent asset percent. By the way, this documentation will be made available on the Help Center with this video. Now I'm going to put in my operation. Do I want to do an average? Do I want to do a sum? Do I want to know the minimum, the maximum? I pick the child asset, which for me will be pump, and then the asset tag, which I'm going to do here. So let's just do what is the average of all of my pumps inside of this district for that flow tag. So now when I look, let's take a look at our error. Can I have a value change triggered rollup expression? Oh, see, I told you these were helpful. I overlooked I need to run this on a period. So we'll do this. We'll run this every 1 hour and we'll reevaluate. So now of all of my pumps that are in this district, I can do a rollup average of the flow tag. At the same time, if I want to know how many pumps are there in this district, I could do an asset instance count. I'm basically using the exact same context here. I'm just not including the average. So I tell it where to look, and I tell it what asset to count. What did I miss on this? Oh, I have multiple rollups in the same equation. Let me delete it. Let's save this. Put our output tag. We'll say flow average calc. Evaluate, apply. Now let's copy this one. Call it asset count. And I'm going to output the asset instant count, and this will be called pump count calc. So how many pumps do I have? I've got 6 pumps. And what is the average of those pumps? That's what's running in my district assets. Now, at the same time, I'm now writing up to my districts. Don't know if we've already beat it. I'll be having for each district, I'll have tags here now. See if I can trigger that rebuild real quick. The views naturally rebuild every 5 minutes, so they discover new tags every 5 minutes. For the sake of speed, I'm going to trick it a little bit. Let's do it this way. If I trigger and edit in my view, I should be able to force it to immediately rebuild. Let's see if we get it. Not yet. I'll have those tags here momentarily. Once you start rebuilding a view, it delays a rebuild so that it's not constantly just rebuilding during this process. But I could then take these tags as they show up, and I could build them into future expressions. So I could, once those tags are part of my asset, I might come back here in just a second and show it to you. Once those tags are part of the highest level of the district asset, they wouldn't have station in front of them. They would just show as district tags. I could rebuild with those tags. So you can see where the health scores now made it back in. The flow 1 hour averages made it back in. And we'll build more on this in calculations 301 as we build out event monitoring so that you have a better understanding in the next course on how to build events and do even higher level with this. But for now, I think we've shown about everything that we hope to accomplish today. Looks like we've probably got some questions. Kyle, you want to take some of the questions that we've received and read them out?
Yeah, definitely. So Dalton brought up a point. He's noticed that the calculation for an interval is the same result as the previous interval calculation, that it won't output a value change since there was no change. So he was wondering if there's a way to force a value change even if there is no change.
Yeah, so good question. Dalton, the historian by nature is update by exception. So within the historian, if whether it's a calculated tag or a tag that we're logging from the field, we are going to ignore the same exact value. So there's not a way to force the historian to take on extra values than are necessary. I'd like to learn a little bit more in your use case. There is a way we can force the historian through a configuration setting to write a value even though it's not necessary. It's not a kind of publicly exposed piece of UI, if you will. So if you can email us at info@canarylabs.com, I'd like to talk to you a little bit more about your use case and see how we can help you solve your problem. Kyle, anything else?
Yeah, then the other one you sort of answered throughout your presentation, but early on asking about the periodic change, if all the calculations for all data would happen in like 5 minutes or just averaging every 5 minutes to run that calculation.
Okay, yeah. I see through the chat that they have the answer to their question. And correct. You mentioned that you can also get that data using the Excel add-in, using the interpolate function, and that is correct. So it's worth mentioning, all of the functions that you're seeing us use here in the calculation server, the majority of those functions we also expose in our other client tools, Axiom, Excel add-in, but most importantly, because we're essentially using the same API between all of our different components to process data. It's the Views API. Even if you're connecting to Canary via a web API, you have access to these same aggregates and functions. So if you're trying to grab data out of Canary and you need to pre-process that data, we can do that work for you so that the data that you're pulling out to bring into another system is already contextualized and cleaned. And I see one more. How did the calc tags that you calculated end up in the main view? Do you have a rule to copy them over? Yeah, so you have to include the new calculated data set in your view. Tell you what, let's take a little bit of time. I want to show that to you. So this view, which we've been building our calculations on, already has the localhost.calcs data set included in the source views. If I edit this, the properties allows me to see those source views or add those source views. Now, this is a good point to bring up for best practice. If I'm just going to show you, actually, let's build a new view. It can be a bit tricky if you don't think ahead on this. Let's build a local view off of the Travis data set. That's part of my water districts. Okay. I want you to notice when there's only one data set called, and that's the Travis data set, that the view naturally cuts the data set off the front of those tag names. So this is the way that it is in the historian. This is the way the view treats it. The second I add another view, that is a semicolon after the first view, and then whatever the second is. I'm going to do Kamal because my tags are formatted the same. The second I add another view, it maintains that data set at the front. So now Travis is pre-pended with the data set. Okay. The reason I bring this up, if all you had in here was one data set, all you're going to see are your tags without that data set name on the front. And what I've seen happen is you come in, you build a bunch of regular expression rules, and you build your model. Then you go and build calculations, and you come back in here and you say, oh, you know what? I want to add those calcs. Well, those calcs come in, and they now trigger Travis to pick up its data set name, and calcs has its data set name. And now all of a sudden your rules don't work. So it's always a good idea as you're building a model, go ahead and build a calculation data set for that model. You're more than likely going to use it. At some point, you're going to use it. So build a dead data set just for the calcs for that model, include it from the beginning, and then that way in the very beginning, you're addressing the rules to trim the front of that data set. Now, you could certainly go in and edit existing. So if I just added that last minute, I could go in and I could come in here and I could look at my rules and I could edit them and I could trim the data sets where appropriate. It's just easier if you build it in for yourself from the beginning. You'll save yourself a little bit of headache if you do it that way. So this merges all assets across views. So this merges all assets across views. Do you have a rule to copy them over? So this merges all assets. Don't know that I understand the intent of your question when you say that it merges all assets across views, all data sets. There we go. Correct. So not only can it merge multiple data sets, but it can also merge multiple data sets and other views. Case in point, Hayes, if we just look at the historian, I want you to look at the way the tags look in Travis. Now look at the way the tags look in Hayes. we're describing the same process. We've got ugly coded tag names. So I built a view that's just aliasing the haze tags. It's changing the haze tags to the standard format. Then this view calls all my other data sets that make up my water districts, and it calls the haze view. So I'm stitching together the work I've done here and the work that's in my other data sets into this view. Then from security, I don't allow my users to see this. I don't allow my users to even see the tags in the historian. I only show my users the tags from this view, if appropriate. Okay, we've answered a lot of questions. We spent a lot of time. I hope this has been helpful. How do we delete a tag? Let's see what you're doing. You're taking me down all kinds of in a calculated data set. Okay, good question. I'm going to answer this one, and then I'm going to encourage you to let's go one-on-one and do some more learning. But actually, yeah, I'm going to answer this one, and there's a follow-up. I'll answer one more. That's a great question. I'm going to give you an example. How about here? Did I have more than one in here? Let's build another one real quick. Let's do a range. A range, and we're not going to want to keep it. So there's my range. Here's the tag. Vibration, and every 30 minutes we'll do the same thing. We'll look at it for the last 4 hours. Output. Say to yourself what I type here. Dataset dot percent asset percent. There it is. Vibration delta 4H underscore calc. I do encourage you to follow this calc labeling on your tags. It really is helpful later on in your Axiom projects. All right, so that's now evaluating. I'm going to tell it to backfill and apply. So state has backfilled, stats is backfilling, number of assets, total properties stored. Let's double check it. I'm going to go look into the historian. Didn't call it range, I called it vibration. So there's my vibration for our delta tags. I need to trigger another, it's because I'm on this 30-minute interval. It's not due to go yet. So here, by clicking remove old data, it would have backfilled had I not already had this in here, but I'm on a schedule now. By clicking remove old data, or by changing something like the start time, by changing something to do here, that is going to cause my calculation then to rerun and to run. You can see it's backfilling now, to rerun and to run appropriately for all of the new tags. It would have done this naturally on the next 30-minute cycle. I've just kind of jump-started it. So there's the vibrations backfill. Now let's get rid of those vibrations. All right, so I have 2 different ways I could delete. So I could just come in here and delete this, make a change, and tell it to remove the old data. So just leave that alone. Or, well, that's fine. We'll leave it at midnight. Apply that. It's going to remove the old data, so it's going to backfill. Notice the output tags have stopped at 47. And when I look here, those tags are now obsoleted. So obsoleted means they're no longer available. On the next rollover, the next time this data set rolls over, those tags will not be in the new HDB file. If I wanted to delete all of my tags in here, when I click the delete, it asks me remove calculated data. So I can delete this only by hitting yes, or I can also obsolete every tag involved in this. All right, let's see if I got another question. What does remove old data do exactly? So remove old data actually deletes the old data and recalculates over top of it. So it's a way, think of it as a way to do a new run on all of the calculations as they've been stored backfilled to a certain date. It can be useful if maybe you've done a massive insert. Maybe you had a lot of devices in the field, you lost connectivity, the calculations ran, and then the next day you realized the storm forward, the buffer cleared, you had all this new data and you wanted to rerun the calculations from the last 2 days. You would come into the calculation. You would say, hey, you know what? I had bad data for the last 3 days. Tell it to remove all data, click, and then it's going to rerun the last 3 days worth of data on those calculations. No longer in Axiom. Okay. Yeah. So once a tag is obsoleted, the client no longer is going to see it. Client has no access to a tag that has obsolete at the front of it in an HTTP file. You are very welcome. And thank you all. It's always great to get on here and have so many people on the call. Thank you. Hey, don't forget, please hop on to helpcenter.canarylabs.com. You can look through a ton of resources. We have spent months of man hours building this thing out, and I'm super excited about this Tesla thing. I think you're going to love it. Even kicking around a really neat Canary DIY kit as well for part of this giveaway. So go get some knowledge and sign up for the giveaway. Remember, you sign up for the giveaway just by joining the community. We're going to do our first big round of merch at 500 users. So have a great day. Thank you, everybody. As always, if you have more questions, info@canarylabs.com.